Now let us consider the following example. We want to solve for mesh currents I1 and I2. To do such, we'll employ our standard 4-step procedure used within mesh current analysis. Step 1 is to construct n KVL loops. We have 2 loops associated with our mesh currents I1 and I2. Note that they start in the bottom left-hand corner and move in a clockwise direction. Step 2 is to assign our voltage potentials consistent with our passive sign convention, and to not duly label any shared elements. Starting with mesh current 1, where we have I1 moving in a clockwise direction, we encounter our 9 ohm resistor, where we apply a voltage potential V1, and then we encounter our current source, which behaves as an active component, such that we apply our active sign convention to it, such that I1 enters the positive terminal of our current source. As we construct our voltage potentials for our second mesh, we notice that our voltage potential across our current source is already assigned, such that we do not change the polarity, and then we encounter our 3 ohm resistor, where we assign V2, and our 6 ohm resistor, where we assign V3. Our third step is to construct n KVL equations, describing each mesh current. For our first mesh, we have the following: minus 12 volts plus V1 plus Vs is equal to 0. For our second mesh current, we have the following: minus Vs plus V2 plus V3 is equal to 0, where our Vs variable is a placeholder that is going to link mesh currents 1 and 2. We're not actually solving for said voltage potential. Step 4 is to apply Ohm's law to express our voltage potentials in terms of our mesh currents. Our mesh current 1 equation becomes minus 12 volts plus I1 times 9 ohms plus Vs is equal to 0. Our second mesh current equation becomes I2 times the quantity 3 plus 6 ohms minus Vs is equal to 0. Or we can express this as Vs is equal to I2 times 9 ohms. Now we have Vs common within each of our KVL equations, such that we can substitute in Vs is equal to 9I2 into our first mesh current equation, such that we have I1 times 9 ohms plus I2 times 9 ohms is equal to 12 volts. We have one equation and 2 unknowns. Lastly, we need to construct a current source equation. Our current source equation states the I2 less I1 is equal to Is, which is 1.5 amps. Now we have 2 equations and 2 unknowns. We can put this in matrix form. We have 9I1 plus 9I2 is equal to 12. This is from the construction of our 2 KVL equations. We also have minus 1I1 plus 1I2 is equal to 1.5 from our current source equation. Thus, our mesh currents are found by taking the inverse of our coefficient matrix, multiplying it by our right-hand side, such that I1 is equal to minus 0.083 repeating amps, and I2 is equal to 1.416 repeating amps. It's noted that the negative sign associated with the I1 indicates that the direction of that current following our mesh loop is actually going counterclockwise.